We're going to do a review of scalars and vectors. Now, if we are going to pause, I'm just going to put the pause. Vectors and scalars. You don't got your name tags out.
Oh, mine's not. Oh,
no.
A scalar shows only magnitude.
A scalar shows only magnitude.
And a vector shows magnitude and direction.
5 minutes is up.
You say you have a different one every day.
Yeah, different one every day.
I should do that.
Oh, me. I enjoyed that. That was funny.
Otherwise, I need to set a timer, otherwise you kind of get, I guess, got to stay on pace a little bit, all right? So vectors, distance, and direction. Can anybody give me a pair of examples? A pair of examples, Aiden?
So like a vector, what do you mean by?
Like an example of a vector and a scalar.
No, so for like a vector would be like the displacement would be 74.
Okay, so displacement would be vector. What's its scalar counterpart? Distance. Okay, who can give me another pair? Another pair. You guys got to put your name tags on, but I can't. Tell me your name. What's your name? Or just tell me. A-Rock. Okay, A-Rock, what do you think? Can you give me another pair?
Vectors on this?
Yeah, vector scalar pair. Like he said, distance and displacement. Can you give me another pair? No? Janaya? Janaya is velocity. Velocity is a what?
Oh, that's
Vector. What's its scalar counterpart? No. What is velocity without direction? Not mass. Speed. Speed, right. Speed is scalar. Velocity is vector. Speed has magnitude only, no direction. Daniel, question?
No, I was gonna say one, but no.
Okay, say one. Which one are you gonna say? There's
Well, I
one
don't
more.
think it's right. Yeah, I think it's like coordinate plane. It's like.
Okay, well, we're using coordinate plane to represent our diagrams, right? Okay. What's another vector quantity that we mentioned yesterday? We had velocity, displacement, and what was the third one?
Acceleration.
Acceleration. Okay? So we're going to talk about velocity and acceleration today. Okay? All right, so that's a little bit of our review from yesterday. First topic. Speed. So if I'm going to define speed, it is going to be defined as distance divided by time. Now, solving problems, whether it's in math or physics or science, we have to treat our numbers like they're bad teenagers. Okay? Nope. You got to be chaperoned. Right? You got to be chaperoned. So, we're always going to have units with every number. Every number needs a unit. So, distance, we can measure in meters. And if we're measuring in meters, we are probably going to use a time unit of seconds. Now, another example, maybe our distance is kilometers. Well, if we're going to use a distance with that big of a unit, we're probably going to want a time unit that's a little bit bigger. Kilometers per second, that's really, really fast.
Minutes?
Maybe minutes or hours. Hours. Okay? Minutes or hours. So those are some units that we'll see when we're talking about speed. And when we're talking about velocity, represented with the letter V, sometimes you'll see V with an arrow over it to indicate that we're talking about a vector. Okay, but I think we know that v velocity is a vector. Formula's going to look very similar. Okay, but since I'm talking about a vector quantity, must mean I need a vector quantity here. So I'm going to think about displacement. Displacement over time. Now, what we're going to notice is we're going to have the same units. We could have, a meter per second. We could have a kilometer per hour. But we're also going to have what else? If we're talking vector quantity, what else are we going to have? These are some units I can have, but I'm also going to have what?
Direction.
Direction. Right, we're also going to have direction.
Wait,
Okay?
is the V signifying velocity?
Velocity. V is signifying velocity.
Is this
I said sometimes you see this little half arrow above it. I'm not going to write it. I'm just going to write V. Okay?
If you put the half arrows, that's still fine.
Yeah, sometimes what you see is, speed might be just V, but if I'm talking velocity, I'll put the vector over it. Okay? But we're just going to deal with the term velocity. Okay? If there's direction given to you in the problem, your answer should have direction. Okay? All right. Now let's talk about something called average velocity. Now we're going to look at average velocity a couple of different ways. Okay? We're going to look at average velocity as a change in displacement over a change in time. Change in displacement over a change in time. So, and I'm going to dazzle you with my beautiful artwork, okay? So brace yourselves. Right? Here's my car. And my car is traveling a certain distance, right? So maybe this is my starting point 0, and I've got a final distance here. And when I put this triangle in front of that, what does that triangle mean?
Change.
Change. It's the Greek symbol delta that means change. So if we're talking about a change, a lot of times we're performing what operation?
You're moving.
What math operation?
Multiplication.
No.
Subtraction.
Subtraction. There we go. Subtraction. Right? Remember when you did slope of lines, change in y over change in x?
Yep.
You subtract it. Okay, so we're looking at change. So if this is 0 and this is 100, my change is what? 100, right? Okay. Another way that we could look at an average velocity, but this is going to be let's look at this car. Okay, here we go. This car driving down the road. Okay? Now, this car driving down the road passed cop.
It's rock.
It's okay. It doesn't need to be on the board. Okay? It's a big chunk off. Just let it run. It'll keep going. Okay. Cop with a radar gun. They're going to be working in pairs. Okay? So you don't like my cop drawing either?
No, it doesn't. It looks goofy.
Well, that's just the way my drawings are. I will tell you right now, there was no art requirement as a math science major. Okay. All right, so let's say that, my car is passing this point in time. And the cop had me going 60 miles per hour.
What's the limit?
60.
Oh, okay.
Some places.
Okay, in some places. But let's say, I'm thinking, I'm in the clear, maybe there's another one, set up down here, with another radar gun, and he gets me going 70. Now, you know when you're driving, unless you got cruise control set, your speed fluctuates, right?
Yes.
All right? So maybe they're thinking, you know what, when we're working in pairs, maybe we'll just cut or brake. Okay? Because if I knew this initial velocity, and here's my final velocity, okay, those are subscripts. I stands for initial velocity, the F, final velocity. Now, assuming that my speed is increasing at a constant rate, I could look at finding my average velocity by taking the two, adding them together, and dividing by 2. In this particular type of scenario. Okay? What is an assumption I'm making here? I'm assuming that my rate increase is constant. Okay, my rate increase is constant. So when this cop is, clocking me with radar, at that point, he is determining my instantaneous velocity. Am I going too fast?
Yes.
No.
Okay, that's my instantaneous velocity. So that is my speed at a particular instant in time. Instantaneous.
Velocity.
Yes, blessing.
What is it?
Okay, because when you're finding an average, like let's say you had a test score of 80%, and then you had 100%.
You add them together and divide by 2.
Right, you had them together divided by 2 because they were of equal weight. Okay. Okay, shh, guys. Say it again. When I'm looking at change, right. I'll do something with that a little bit later. Okay, but this was change in distance over time. This is just looking at two velocities to get an average. Okay, so like clocking the two different places and averaging them together, just like you would average your test scores, gives me a rounded, more well-rounded answer. Yes.
So in this case, your I and F would be 60 and 70.
Yes. Okay. All right, did you guys get something down for?
Wait, so average velocity is on top and instantaneous velocity.
Well, no, this is just, I'll define instantaneous and run over it. Okay, both of these are average velocities. Okay, just two different ways of looking at average velocity. I could look at it from the whole length of a trip standpoint. Going 100 meters, I know the time it took me. Okay? This other scenario is when my trip is not staying at a constant rate here. I'm starting off at this point 60, and then down the road I'm going 70. Now what was my speed? Well, we might take an average. Average the initial plus the final divided by 2. Just like you would do your grade. If you had an 80 on the test and a 100 on the test, what would your average be? 90.
Yeah, I would just 65.
65? 65, right. Okay, so my average here is going to be 65 miles per hour. Is he still going to give me a ticket?
No.
Probably. Okay. All right. He's just taking those two instantaneous velocities. Okay, did you guys get something down for instantaneous?
Yes.
Okay, speed at any instant in time. Okay, instantaneous velocity, speed at any instant in time.
Say one more time, please.
Speed at any instant in time.